Hello world! On this video we are going to review the Hexagonal Architecture. It is a software design pattern to develop applications that are highly maintainable. This design pattern is also known as the ports and adapters. The concept of hexagonal architecture was introduced by Alistair in 2005 as a solution to structural issues on object-oriented systems. The idea behind hexagonal architecture is that the fastest we can apply changes to a system, the better. This pattern reduces the amount of technical debt in a system, and software applications become easier to maintain. This pattern is usually represented as an hexagon. However, this does not imply that applications implementing the pattern should have 6 ports. The decision to use an hexagon was to allocate enough space to show the diagram. The first concept to review are the ports. Ports are interfaces defined by the core of an application to expose data format and boundaries. External services need to respect the format of the ports. Ports can be classified as primary ports, the entry point of an application with the outside world. They drive the application. Usually, the upstream is a client request, while a downstream is the data of the response. In the graphical representation, primary ports are usually located on the left side of the hexagon. Secondary ports. In the opposite side of the hexagon, we have the ports that are driven by the application. They are located on the far right side of the graphical representation, and they are used for the application to pass or receive data from outside entities. The most common use case are databases. There is not a fixed number of ports in hexagonal architecture. It is up to developers to decide how many ports should a system have according to the application needs. An extreme case will be adding a new port per each use case, leading to hundreds of application ports. On another extreme case, we could merge all primary and secondary ports so that the application ends up with only 2, the left side and the right side. Finding the right balance is usually the best choice. Another key concept in hexagonal architecture are adapters. They are used by outer layers to connect and use logic of the inner layers. They are key to this pattern as they allow for a custom implementation of the core without impacting the internal logic. External services can connect to ports via adapters and apply data transformation without affecting the core. What this means is that each adapter can handle data in a custom way. As an example, to trigger an application from a testing software or from a user device. The adapter in each case is going to be different, but the core logic of the application remains the same. The hexagonal architecture is a design pattern that has been evolving over time. Some developers see it as an evolution of the onion architecture. Others just consider that the pattern does not concern about the project layers itself. In any case, for this explanation we are going to consider which are the conceptual layers that are used by hexagonal architecture. The conceptual layers can be organized as the domain layer, which handles the core logic of the system, the application layer, which manages events from outside layers, and the inner core, these are the ports and adapters, and then we have the framework, which is responsible for interacting with the outside world. The key principle of this pattern is that inner layers are not aware of their outer layers. This ensures that the core business logic of your application is not going to be affected by any of the external services. Dependency injection is then used at the runtime to pass dependency classes from high levels to lower levels. The hexagonal architecture is a software design pattern that can be applied to any project. It is extremely helpful for software applications that are composed by multiple external entities. Hexagonal architecture also facilitates the unit testing of the application. The best practice to follow is to write use cases for the internal core of the application and do not take into account external services which drive the application. That leads to small test cases which are cleaner and easier to understand. It is a common mistake to write test cases which have knowledge from external services beyond ports and adapters. These use cases are usually long and complex to maintain. Here we're going to do a comparison between the pros and cons of this design pattern. On the positive side of the hexagonal architecture, we have that applications using this pattern are easier to maintain. New external services can be plugged into the system via adapters and the core business logic will not get impacted. It creates systems with friendly testing and with easy setup. In hexagonal architecture, it is easy to replace technology of external services without impacting the core business logic. On the negative aspects, we have an additional complexity as the pattern requires more layers on top of the architecture. The addition of boards and adapters require many mappers and value objects. As the core layer has to be completely independent from the outside world, entity objects and interfaces from outside services might get duplicated in order to keep the business logic independence. This is especially the case for systems using the microservice pattern. As we've seen, hexagonal architecture is a design pattern that is great for creating systems easier to maintain. However, it is not suited for all types of application, so it is up to developers to find the best pattern for each case. Thanks for watching this video. Hopefully you learned something new and maybe I will see you in another video of software design patterns.